beneath a shell of ice colder than anywhere on Earth, hidden from sunlight and hundreds of millions of miles from home, there may be more liquid water than exists in every single ocean on your entire planet combined. This is Europa, one of Jupiter's icy moons, and what would actually happen if you tried to survive there reveals one of the most compelling possibilities for alien life anywhere in the solar system. Start with what you would face the moment you stepped onto Europa's surface. Unlike Jupiter itself, Europa does have a solid surface, but that surface is almost entirely made of water ice, smooth in some regions and dramatically cracked in others, crisscrossed by long reddish-brown streaks that stretch for hundreds of miles across the moon. Temperatures on Europa's surface average around negative 260 degrees Fahrenheit, cold enough that without immediate and extremely advanced protection, you would freeze solid within seconds of exposure, long before any other danger had the chance to affect you. Radiation would be an equally immediate threat. Europa sits deep within Jupiter's powerful magnetosphere, the same intense radiation environment that makes approaching Jupiter itself so dangerous. Exposure to this radiation on Europa's surface would deliver a lethal dose to an unprotected human body within a matter of hours, meaning any realistic survival scenario would require you to get beneath the ice as quickly as possible, both to escape the radiation and to access the true reason scientists find Europa so fascinating in the first place. Here is the detail that makes Europa one of the most exciting targets in the entire search for life beyond Earth. Scientific evidence, largely gathered from NASA's Galileo and Juno missions, along with detailed observations from the Hubble Space Telescope, strongly suggests that beneath Europa's icy outer shell lies a massive, global ocean of liquid salt water, potentially containing more than twice the total volume of water found in all of Earth's oceans combined. This ocean is believed to be kept liquid not by heat from a nearby sun, since Europa receives only a tiny fraction of the sunlight Earth does, but by a process called tidal heating, where the immense gravitational pull from Jupiter constantly flexes and stretches Europa's interior as it orbits, generating enough friction and heat to keep this vast ocean from freezing solid despite the moon's extreme distance from the sun. If you somehow manage to drill or melt your way down through Europa's icy crust, estimated to range anywhere from about 10 to 15 miles thick in various models, you would eventually reach this hidden ocean. And this is where the scenario becomes genuinely thrilling from a scientific perspective. On Earth, scientists have discovered entire ecosystems thriving near hydrothermal vents at the bottom of the ocean, in complete darkness, without any direct sunlight at all, relying instead on chemical energy released from the seafloor itself through a process called chemosynthesis. If Europa's rocky seafloor experiences similar hydrothermal activity, driven by the same tidal heating that keeps its ocean liquid, it is entirely possible that similar chemical energy sources could exist there too, potentially providing exactly the kind of environment needed to support simple microbial life, completely independent of sunlight. This possibility is precisely why Europa has become one of the top priorities for future space exploration missions. NASA's Europa Clipper mission, which launched in October 2024, is specifically designed to conduct detailed flybys of Europa, studying its icy shell, subsurface ocean, and potential habitability without actually landing on the surface, gathering crucial data that scientists hope will help determine whether Europa's hidden ocean truly has the right conditions to support life. Now imagine you actually reach that ocean yourself, submerged in freezing, pitch-black saltwater under crushing pressure from the miles of ice above you. Visibility would be essentially zero without artificial light, since no sunlight penetrates through Europa's thick, icy shell. The pressure at the base of that ice, combined with the weight of the ocean itself, would be substantial, likely comparable to some of the deepest points found in Earth's own oceans, requiring serious engineering to survive without being crushed. Temperature within the ocean itself, however, might actually be less extreme than the surface, since liquid water fundamentally cannot exist below its freezing point, meaning conditions directly within Europa's ocean could theoretically be more survivable, at least in terms of temperature, than the brutal cold of the icy surface above. What makes Europa such a compelling scientific target, more than almost any other body in the solar system, is that it checks nearly every box scientists look for when searching for potentially habitable environments beyond Earth: liquid water, a stable heat source, and likely chemical energy from the seafloor, all hidden safely beneath a protective layer of ice that shields it from Jupiter's deadly radiation. While no human being could realistically survive the extreme cold, crushing ice, and intense radiation required to reach that hidden ocean today, Europa remains one of the most promising places in the entire solar system where scientists genuinely believe alien life, even if only simple microbial life, could actually exist right now, quietly surviving in the dark waters beneath our neighboring planet's icy moon. If Europa's hidden ocean just blew your mind, make sure you hit subscribe, drop a like, and leave a comment telling this channel which world it should explore next, because there are countless more cosmic mysteries waiting to be uncovered right here on this channel. Coming up next, get ready to rethink everything you know about time itself, because this channel is exploring what would actually happen if you traveled faster than the speed of light, and why the universe itself might refuse to let you.